In this lesson, we will delve into Task 5.2.1 of Project 2, which focuses on the structural forms of the single support boring fixture. The single support boring fixture plays a crucial role in the field of machine tool processing. Its various structural forms directly impact the precision, efficiency, and quality of the boring process. Next, we will explore in detail the various structural forms of the single support boring fixture, along with their characteristics and application scenarios. In machine tool processing, a boring fixture is an important type of jig used to ensure the positional and dimensional accuracy of bored holes. As a type of boring fixture, the single support boring fixture has unique structural characteristics and applications. Basic concept of single support boring fixture. Simply put, a single support boring fixture is a boring fixture structure that uses only one support point to support the boring bar during the boring process. Compared to multi-support boring fixtures, this structure has advantages such as relatively simple structure and lower cost, but it also has certain limitations in some aspects. Since there is only one guiding support, the boring bar is fixedly connected to the spindle. The rotational accuracy of the spindle will affect the accuracy of the bored hole. Classification of structural forms of single support boring fixture. Front support boring fixture. A front support boring fixture refers to a boring fixture structure where the support point is located in front of the tool. In this structure, the front end of the boring bar is supported by the support sleeve of the boring fixture, while the rear end is connected to the machine tool spindle. Characteristics. Since the support point is at the front, it can effectively reduce the deformation of the boring bar under cutting forces, thereby improving the accuracy of the bored hole. Additionally, this structure facilitates observation and measurement of the machining process, making operation relatively convenient. Application scenarios. Suitable for machining parts with smaller diameters and shorter hole lengths. For example, in the machining of small mechanical parts, such as instrument components and small molds, the front support boring fixture can effectively meet the processing requirements. Mechanical principles. From a mechanical perspective, in the cutting process, the support point of the front support boring fixture can bear part of the cutting force, thereby reducing the cantilever length of the boring bar and decreasing its bending deformation. According to the bending theory of beams in material mechanics, the amount of deformation of a beam is directly proportional to the cube of its length and inversely proportional to its flexural rigidity. Let the length of the boring bar be L and its flexural rigidity be EI. Under the cutting force, F, the maximum deformation delta of the boring bar can be approximately expressed as delta equals F times the cube of L divided by 3 times E times I. From the structure of the front support boring fixture, it can be seen that by setting a support point at the front, the effective length of the boring bar is effectively reduced, thereby significantly decreasing the deformation and improving machining accuracy. Rear support boring fixture. A rear support boring fixture is a boring fixture structure where the support point is located behind the tool. In this structure, the rear end of the boring bar is supported by the support sleeve of the boring fixture, while the front end performs the cutting operation. Characteristics. The structure of the rear support boring fixture allows the boring bar to maintain better stability during the machining process, reducing the impact of vibrations. Additionally, since the support point is at the rear, it does not interfere with the installation and adjustment of the tool. Application scenarios. Suitable for machining parts with larger diameters and longer hole lengths. For example, in the machining of large mechanical parts, such as engine blocks and large housings, the rear support boring fixture can provide better support and stability. Mechanical principles. During the cutting process, the rear support point can effectively limit the displacement of the rear end of the boring bar, making the deformation of the boring bar under cutting forces more uniform. According to the principle of mechanical equilibrium, the rear support point can bear part of the reaction force of the cutting force, thereby ensuring the stability of the boring bar. Let the cutting force be F and the reaction force at the rear support point be R. The boring bar is in a state of equilibrium under the action of the cutting force and the reaction force. Thus, F equals R in an ideal situation, ignoring other influencing factors. By reasonably designing the position and structure of the rear support point, the force distribution on the boring bar can be optimized, thereby improving machining quality. Combined front and rear support boring fixture. A combined front and rear support boring fixture incorporates the characteristics of both front and rear supports, with support points set at both the front and the rear ends of the boring bar. Characteristics. This structural form can maximize the rigidity and stability of the boring bar, reducing its deformation and vibration, thereby achieving higher machining accuracy. Application scenarios. Suitable for machining parts that require extremely high precision, such as high-precision molds and aerospace components. Mechanical principles. The combined front and rear support boring fixture effectively provides constraints at both ends of the boring bar, making its force-bearing state more akin to that of a simply supported beam. According to the bending theory of simply supported beams, under the same cutting force, the deformation of a simply supported beam is much smaller than that of a cantilever beam. Compared to a cantilever beam, the combined front and the rear support boring fixture can significantly enhance the rigidity of the boring bar and improve machining accuracy. Key design points for single support boring fixture. When designing a single support boring fixture, the following key aspects need to be considered. Selection of support sleeve. The precision and the material of the support sleeve directly affect the support effectiveness of the boring bar. Generally, the support sleeve should have high precision and wear resistance, with common materials being bronze, cast iron, etc. Determination of support point position. The position of the support point should be reasonably determined based on the machining requirements of the part and the force conditions of the boring bar. While ensuring machining accuracy, the cantilever length of the boring bar should be minimized as much as possible. Structural rigidity of the boring fixture. To ensure the stability of the boring fixture during the machining process, the structure of the boring fixture should have sufficient rigidity. This can be achieved by increasing the wall thickness of the fixture and arranging reinforcing ribs in a reasonable manner. Ideological and political elements. The mechanical wisdom in the single support design of heavy machine tools as a metaphor for an independent development path. The single support design of heavy machine tools embodies rich mechanical wisdom. Designers skillfully apply mechanical principles to reasonably design the support structure, enabling the machine tools to maintain machining accuracy while reducing costs and improving efficiency. This deep understanding and application of mechanical principles reflect China's independent innovation capabilities in the field of mechanical manufacturing. From an ideological and political perspective, the success of the single support design in heavy machine tools metaphorically represents China's spirit of independence and self-reliance in its industrial development path. In the face of foreign technological blockades and competitive pressures, Chinese researchers and engineers have relied on their own intelligence and efforts to overcome numerous technical challenges, achieving independent research, development, and the production of high-end equipment such as heavy machine tools. This inspires us to also promote the spirit of independence and self-reliance in our studies and work. We should be brave in exploration and innovation, relying on our own abilities to solve problems and contribute to the development of the country and the rejuvenation of the nation. In this lesson, we primarily discussed task point 5.2.1, which focuses on the structural form of the single support boring fixture in Project 2. We first introduced the basic concept of the single support boring fixture. Then, we provided a detailed explanation of the characteristics, application scenarios, and mechanical principles of the three structural forms: front support boring fixture, rear support boring fixture, and a combined front and rear support boring fixture. Additionally, we mentioned the key design points for the single support boring fixture. Furthermore, we explored the spirit of independence and self-reliance embodied in the single support design of heavy machine tools from an ideological and political perspective. I hope that through this lesson, everyone has gained a deeper understanding of the structural forms of single support boring fixtures and can apply the knowledge learned to actual machine tool processing.